Let's continue our discussion on similar triangles by taking a look at question 3. We have angle PST congruent to angle PRQ, giving us one set of angles congruent. And if I'm looking at my little small triangle and my large triangle, I'm noticing that something's overlapping here. So I know that angle P is congruent to angle P. So number 2, this is our reflexive property. So now that I know that I have 2 sets of corresponding angles equal, I'm going to say that triangle PST is similar to triangle PRQ. We're going to use our angle theorem to justify why those are similar. So now I'm taking a look. I've got PS and PR over PT to PQ. So notice that I have sides are corresponding. So step 4 here, I'm going to make a proportion. So PS over PR is equal to PT over PQ. And much like the last one, the corresponding sides of similar triangles are in proportion. Moving on to number 4. This time I have 2 sides that are parallel to each other. So I have VW parallel to XY. And again, I'm trying to show that I have some sort of cross multiplication. So remember that we have a proportion and it's cross multiplied. Okay, so that's what we're looking to do here. So if we know that we have, there's a couple of different ways that we could do this. And one way that we could show this, though, is since our lines are parallel, I know that angles that correspond to each other have to be congruent. So I can use both of those angles right there. And that's going to help me because then I don't have to use angle Z at all. So this will get this done all in one step. So I'll know angle 1 congruent to angle 2, angle 3 congruent to angle 4. And my reason is that we have parallel lines cut by a transversal and they have congruent corresponding angles. So now I know that my triangle ZVW is similar to triangle ZXY. And again, we're using our angle theorem. Notice we've used that theorem an awful lot when we're proving that things are similar to each other. So now I want to take a look at what kind of proportion I need to create. So we have VZ and we have WZ. We then have YZ. We also have XZ. So again, lots of different ways that we can set this proportion up. So if I do something like VZ over XZ, that's the same as WZ over YZ. So the corresponding sides of similar triangles are in proportion. So now I want to cross multiply those. So VZ times YZ is equal to WZ times XZ. And our new fancy phrase, the product equals the product of the extremes. Now, describing a series of similarity transformations that maps them onto each other. So what I want to do is I want to dilate triangle VZW, and I want to describe what my scale factor is. So my scale factor, I'm going to use XZ over VZ, so that if I multiply my scale factor times VZ, I end up with XZ, and I do want to be specific that it is from point C. Now I want to describe where my angle V maps to where angle X is, angle W maps to where angle Y is, and my angle Z doesn't change. So angle Z remains fixed. So since dilations preserve our angle measures, then my triangles are going to stay similar to each other. So Z, X, Y, similar to triangle